You're looking at a million tiny water droplets right now, and every single one of them is secretly a light-splitting machine. From core to sky, it's time to chase the rainbow. Let's be honest, you've seen a rainbow, thought, wow, pretty, and moved on with your life. But what you just witnessed was one of the most elegant physics experiments in nature, and it's happening in every single raindrop, all at once, just for your eyes. Let me break this down. 2 key ingredients go into making a rainbow: sunlight and suspended water droplets. That's it. No magic, no unicorns. Just light and water doing something absolutely wild together. Here's the thing about sunlight that most people don't think about. The light we get from the sun is something called white light, and it's composed of all different colors: red, orange, yellow, green, blue, indigo, and violet. Every color you could ever imagine is already hiding inside that one beam of plain white sunlight. It's basically a color party that nobody told you about. So what happens when that party crashes into a raindrop? When sunlight enters a raindrop, it gets refracted. That means bent. Because of the density difference between air and water, then it gets reflected at the back of the droplet, and finally refracted again as it exits. Light of different wavelengths bends at slightly different angles, separating sunlight into an array of colors as it leaves the water droplet and enters our eyes. Think of it like this. Imagine you're walking on a sidewalk, and you step onto wet grass at an angle. You slow down on one side first, which makes your whole body turn. That's basically what happens to light. It hits the denser water, slows down, and turns. And because each color of light has a slightly different wavelength, each one turns by a slightly different amount. Longer wavelengths appear as red, and shorter wavelengths appear as blue or violet. So the colors that were all jumbled up together in white light, they fan out, separated, sorted, like the universe doing its own laundry. Now here's where it gets even cooler. The science involves 2 key processes: refraction, which is the bending of light, and reflection, which is the bouncing of light. When sunlight enters a round raindrop, it first refracts and then reflects off the back wall inside the drop, and then refracts again on the way out. So the rainbow isn't just a window, it's a tiny mirror and a prism at the same time. One raindrop is doing the job of an entire optic slab. Overachiever. And the colors always come out in the same order. There are 7 colors in a rainbow, always in the same order, from outside to inside: red, orange, yellow, green, blue, indigo, and violet. The easiest way to remember them is with the name Roy G. Biv, the most famous person who has never existed. Now here is a question that sounds simple but will genuinely mess with your brain. Why is a rainbow shaped like a bow? Red light exits each raindrop at an angle of 42 degrees, while violet exits at a slightly smaller angle of 40 degrees. The different angles from millions of droplets combine to form a complete circle of color in the sky. That's right, a rainbow is actually a full circle. Since the raindrop is circular, the reflection it creates is also circular. We don't see a full circular rainbow, however, because the earth gets in the way. The ground ruins the show. Typical. Though pilots and people at the top of mountains sometimes see the full circle. Lucky them. And here's something that will change the way you look at rainbows forever. Rainbows aren't solid objects you can touch or reach. They're actually optical illusions. They're caused by the way light travels in your eyes. This is why you can never find the end of a rainbow no matter how far you walk towards it. It moves with you. Your rainbow is literally built just for your viewing angle. The person standing next to you is technically seeing a completely different rainbow, built from completely different raindrops at a completely different angle, turned to their eyes. That's either deeply beautiful or deeply unsettling, depending on your mood. The scenic views that the nature sets up, the natural sounds that you hear, it really puts your mind at ease and gives you a sense of peace. And I was speaking to a friend of mine, and he told me that he can actually recreate that whenever you want. You don't have to wait for a rainbow to appear every time. And so I was like, all right, worth a try. And I gave it a try, and it wasn't bad. I'll leave the link to it in the description as well as in the pinned comment, something that you can look at if you're interested or not. It helped me, so I thought it helps you the way it helped me. Anyway, Anyways, back to the video. Speaking of angles, this is why we only see rainbows when the sun is low and behind us, and most likely after rain when the air is extra moist, full of suspended droplets. You need the sun at your back, the rain in front of you, and the geometry has to line up just right. You can only see a rainbow when raindrops fall in the direction of 42 degrees from your shadow, and the sun's elevation is less than 42 degrees above the horizon. Miss that angle? No rainbow. The universe is particular about this. Now, about double rainbows. Sometimes, a viewer may see a double rainbow, a faint secondary rainbow appearing above the primary one. Double rainbows are caused by light being reflected twice inside the raindrop. As a result of this second reflection, the spectrum of the secondary rainbow is reversed. Red is on the inner section of the arch, while violet is on the outside. The colors flip. The second rainbow is basically the first one's evil twin. Same arc, same colors, just upside down and a little dimmer. More reflection also means longer paths for the light to reach our eyes, making secondary rainbows much fainter than the primary. And wait, could there be a third rainbow? Theoretically, sunlight can undergo even more reflections inside water droplets to form triple rainbows. But if you've ever seen a double rainbow, you might have noticed how dim the secondary rainbow appears. A third arc would be even dimmer and harder to witness. So yes, triple rainbows are physically possible. They're just incredibly difficult to see. And honestly, at that point, light is just showing off. Oh, and one more thing. You don't need rain at all. Rainbows can be caused by many forms of airborne water, not only rain, but also mist, spray, and airborne dew. Garden hose, waterfall, foggy mornings, all potential rainbow machines. And if you're up at night, a moonbow, also called a lunar rainbow, is a rainbow produced by the light reflected by the moon. The moon itself doesn't emit light, of course. Moonlight is reflected sunlight. Because moonlight is so much fainter than sunlight, moonbows are dimmer than rainbows. They're so faint our eyes can barely detect the color, but cameras can pick it up. A rainbow built from borrowed sunlight. Poetry, honestly. And here's the record for how long this whole light and water show can run. You can usually see rainbows in the sky for about an hour, but in 2017, a record-breaking rainbow was documented in Taiwan, which apparently lasted 9 hours and was witnessed over the Chinese Culture University in the mountains of Taipei, which is the capital of Taiwan. 9 hours. The longest rainbow ever recorded. That's not a weather event. That's a commitment. So the next time you see a rainbow, here's what's actually happening. Millions of tiny water droplets are each acting as a personal prism, bending, splitting, and bouncing light at exactly the right angles to deliver a sorted spectrum of colors directly to your eyes and your eyes alone. Every time you see a rainbow, you're watching sunlight perform an amazing trick. Bending, bouncing, and splitting as it travels through millions of tiny raindrops. It's not magic, it's physics, and honestly, physics is cooler. Alright, that is it for today. We will be discussing more cool concepts like this in the future videos, so go ahead and subscribe so you do not miss out on those videos. Also, if you found this video informative and helpful, like the video and comment below what you would like to see in the future and what you think of this lovely illusion performed by physics and nature.